Hello, and thanks for clicking on this next Narculus production. Today we're going to talk about AP FRQs that involve the net change theorem. So this should be pretty exciting. You worked on some of the problems there, so now let's see those solutions. Okay, all right, let's give it a shot. Here we go. Okay, so the figure above shows the graph of f prime, so that's important. You have the graph of f prime in front of you, the derivative of a twice differentiable function f on the interval -3, 4 closed. The graph of f prime has horizontal tangents at the 3 points that are given. The area of the regions bounded by the x-axis and the graph of f prime on -2 to 1 and 1 to 4 are 9 and 12 respectively. So the area from -2 to 1 that's bounded there is 9, but it's underneath the x-axis, so it's really -9. So I'm going to put that in there so that I have it. And then the area from 1 to 4 is 12, but again, it's underneath the x-axis, so it's going to be considered negative. Okay, so given that f of 1 is equal to 3, write an expression for f of x that involves an integral. That is the first question. Write an expression for f of x that involves an integral. All right, so then to find f of x, to find the value of f at any number, okay, x, well, you're given f prime, not f. So you're going to have to integrate from, well, where are we going to start from? Well, we need a place to start from. We're going to start here at f of 1, right? That's a place to start from. We know the value is 3. So f of x will be equal to f of 1 plus the integral from 1 to wherever we're going to stop, whatever x value they want us to stop at, of this function that's given, f prime t dt, right? Because that will tell us how far or what the total is based on the rate. Given the rate, integrate it, you'll get the total. This is the total amount, okay, over the time interval. And we add on wherever we started from. So f of x is really 3 plus the integral from 1 to x of f prime t dt. Okay, there is your answer for the expression of f of x. Then they want you to find f of 4. So to find f of 4, well, f of 4 is going to be f of 1. So this is where we end. It's going to equal to where we start plus the integral from 1 to 4. So we're starting from x equals 1. We want to stop at x equals 4, f prime t dt. Okay, so then f of 4 will just be, well, let's see, f of 1 is 3 plus the integral from 1 to 4 of f prime t, that's the area that's underneath this curve. Well, the area under the curve is -12 from 1 to 4, which gives me -9. So f of 4 must be -9. And then they also ask you to find f of -2. So f of -2 is f of 1. So this is where we want to end up. We're going to start from f of 1. That's the only value we know on f. Plus the integral from 1 to -2 of f prime t dt. We got to work from where we're going to start to where we're going to stop. Now the problem with this is that the bounds are backward, right? So we have to reverse the bounds, but we can do that by negating the integral. So f of 1 is 3 minus the integral from -2 to 1 f prime t dt. So that's going to be 3 minus from -2 to 1 f prime, the integral, that's the area underneath this curve again. So the area underneath the curve from -2 to 1 is -9. So now we have 3 minus -9, which is 12. So f of -2 is 12. And those are your answers to these 3 questions that they're posing here in part D. And there are 3 questions. You'd have to answer all 3 to get full credit. Okay, let's try another one here, the next one here. All right, so now, same idea. You're given the graph. The graph is the graph of f prime. Again, okay. They tell you about horizontal tangent lines. The areas are already given to you in here. This area is 2. That area is 6. This area is 3, but it's negative, so I'm going to call it negative 3. And this is 7, so I'm just going to write it a little bigger so I can see it. Okay, those are my 4 areas that I'm given. And I also know f of 8 is equal to 4, so I have a place to start from. So this is where I would start from. Now, it wants you to determine the absolute minimum value of f on the closed interval 0, 8. 0, 8 closed. Okay, so the interval is closed. There's a couple things going on here. The interval is closed. I want not just the minimum, the absolute minimum. Okay, it's not a relative minimum. I'm looking for the absolute minimum. All right, value of f. Okay, not of f prime. So this graph doesn't just tell me what the answer is on the closed interval 0, 8. So I want the absolute min on a closed interval. This is an election candidate's problem. This is a candidate's problem. All right, so to find the candidates, so my candidates are always, well, first of all, to find a min at all, you need to take the derivative of f, right? I want the minimum of f. So the derivative of f would be equal to 0. That's where my critical numbers are. So my critical numbers are going to be 1, 2, 3, 1, 2, 3, 4, 5, 6. So those are my 3 critical numbers. X equals 1, x equals 4, x equals 6. They are all candidates in this election. And then both the endpoints count because the interval is closed. So x equals 0 counts, as well as x equals 8. Okay, all 5 of these are candidates for this absolute minimum value election. Now, how do I find, for example, the y value? Because that's what I want you to do, right? Find the absolute minimum value of f. Well, how would I do it if I gave you a function f of x? You'd find the derivative, you'd find the critical points, and then you take the critical points and the endpoints, all the candidates, and plug them into the original f of x, right? And figure out which one is the biggest loser and which one's the biggest winner. Okay? But here, I don't have f of x. All I have is a graph of f prime and a place to start on f of x. So we can figure out what f of 1 might be. So f of 1 will be f of 8, that's where we start from, plus the integral from 8, where we're starting from, back to 1 of f prime x dx. So now I need to find this value. So let me do it down here. All right, so f of 1 is going to be f of 8, which is 4. Now the bounds are backward, minus the integral from 1 to 8 of f prime x dx. So that's 4 minus whatever's going to be in the quantity from 1 to 8. So in there we have 6 minus 3 plus 7, which is 4 minus 10, negative 6. So we'll write them over here. F of 1 is negative 6. Okay, now f of 4, same idea. F of 4 is f of 8 plus the integral from 8 back to 4 of f prime x dx. All right, so we'll come over here and do it. F of 4 is going to be 4 minus the integral from 4 to 8 of f prime. That's going to be 4 minus from 4 to 8. That's negative 3 plus 7, the area under the curve. So that's 4 minus 4, it's 0. So f of 4 is 0. F of 6, same thing. F of 8 plus the integral from 8 back to 6, f prime x dx. So f of 6 is going to be 4 minus the integral from 6 to 8. So from 6 to 8, it's 7. So that's -3. So f of 6 is -3. F of 0 will be f of 8 plus the integral from 8 back to 0 of f prime x dx. So f of 0, I'm going to come down here. It's going to be 4 minus, again, from 8 to 0, the bounds are backwards. We'd have to switch them around. So it would be 4 minus 2 plus 6 minus 3 plus 7. So that's 4 minus 8, and 7 is 15 minus 3 is 12. 4 minus 12, -8. So f of 0 is -8. And then finally, f of 8, that's easy. That's 4. There, literally, it tells us. So the absolute minimum value, remember that means a y value because I don't say that have the letter x in front of the word value. So that means y value. The absolute minimum value is -8 here at f of 0. That is the smallest y value of the 5. Now, the other thing you could do, which some of you may have recognized at one point or another, is it asks you for the absolute minimum value. So I'm sure some of you looked at this graph and said, well, this is the graph of f prime. This point at x equals 1, the graph doesn't change sign. There's not a relative min or max here at this point. Or at this point here at x equals 4, there's going to be a relative max on f, because f prime changes from positive to negative. Okay, and then the only relative min on the graph appears right here at x equals 6, right? So some of you are probably thinking, well, why am I going to even waste my time with x equals 1 and x equals 4? Because there's no way they're going to be the answer. This point here is a max on f, and this point is neither a min or a max. This is the only min, okay? But since it's an absolute minimum value that I'm asking you for, then there are, in fact, 5 candidates. The candidates for election here are where there are a critical number, the derivative is equal to 0, or the endpoints. Those are the 5 candidates. Now, what you could have done, instead of finding its y value, is you could have told, okay, written next to x equals 4, well, at x equals 4, f prime changes from positive to negative. It's a relative max, so it can't be the absolute min, or it can't have the absolute minimum value. That would be acceptable, okay? Same thing with x equals 1. Well, the graph doesn't change sign here, so this is not a min nor a max, so there's no way that's going to end up being the absolute max, or the absolute min. You could have done that. You could have explained it away, but you have to explain it away or show them mathematically, numerically, that it's not going to be the correct answer. You can't just ignore those values, okay? And thanks for clicking.